Hey guys, welcome back to my channel. Today we're going to do questions and sequences. These questions are going to be simpler questions compared to the ones that are in the grade 7, 8, 9 part. And through these questions, you'll be able to better understand how arithmetic sequences questions work and how you're supposed to find the nth term, how you're supposed to find a missing term or sum of terms. So let's start with the first one. It says that here are the first four terms of arithmetic sequence: 38, 31, 24, 17. Find an expression in terms of n for the nth term of the sequence. So in your formula sheet, we're given the formula for the nth term, which is the nth term equals to a plus n minus 1 times t. Now, a is your first term, n is your number of term, and d is your common difference. So when a sequence is given, you can easily identify your first term and your common difference. This is your first term, and common difference is going to be the difference between each consecutive term. So you can pick any two consecutive terms and it'll give the same difference as any other consecutive term would. So if you do 31 minus 38, that gives you -7. So that is your common difference. Remember, for the common difference, to subtract the smaller term from the bigger term. And by that, what I mean is that this is the first term, this is the second term, third term, fourth term. So we will do fourth term minus third term, or third term minus the second term, or the second term minus the first term. This is what I mean by a bigger and smaller term. So common difference is -7. First term is 38. So we have to find an expression for the nth term of the sequence. So the nth term is going to be 38 plus n minus 1 times -7. The reason why n remains as it is because it's saying the nth term. It's not saying the first term, the second term, third, fourth, 10th, 11th. It's the nth term. Then we expand the bracket. So 38 minus 7n plus 7. 38 plus 7 is going to give us 45. So 45 minus 7n is your nth term expression for this sequence. Very simple. You need to know the formula, which is already given in the formula sheet. And then you just identify your first term and your common difference value, substitute it, simplify the expression, and you have your nth term expression. In the next question, it says that the arithmetic series has first term 1 and the common difference is 4. We have to find the sum of all terms of the series from the 41st term to the 100th term inclusive. So the sum formula is sum of n terms is n over 2 times 2a plus n minus 1 times d. So they want to find the sum of all terms of the series from the 41st term to the 100th term inclusive. So if we find the sum of the first 39 terms and the sum of first 100 terms, subtract the two, that would give us the sum of the terms from the 41st term. If we find the sum of the first 40 terms and the sum of the first 100 terms, and when we subtract the two, that will give us sum of the terms from the 41st term to the 100th term inclusive. So S40 is going to be 40 over 2 times 2 times 1 plus 40 minus 1 times 4. 40 divided by 2 is 20. 2 plus 39 times 4, that's 156. So 156 plus 2, 158 times 20, and that's 3,160. Now I find some of the first 100 terms. So that's 100 over 2 times 2 times 1 plus 100 minus 1 times 4. So that's 50 over here, and 2 plus 99 times 4, which is 396. 396 plus 2 is 398 times 50. That's 19,900. 900. So to find the sum of all the terms from the 41st term to the 100, we will do 19,900, which is sum of the first 100 terms minus the sum of the first 40 terms. That is going to give us the sum of the 41st term to the 100 term. So 16,740. That is your final answer. The next question says here are the first 5 terms of a number sequence S. 10, 16, 22, 28, 34. Find an expression in terms of n for the nth term of the sequence. So we're going to do the same thing. First term is 10. Common difference is 16 minus 10, which is 6. So the nth term formula is 10, which is the first term, plus n minus 1 times the common difference, which is 6. So 10 plus 6n minus 6. 10 minus 6 is 4. So 4 plus 6n is your answer. Then it says the nth term of a sequence T is given by n square minus 3. There are numbers that are terms in both the sequence S and sequence T. Find one of these numbers. So to find one of these numbers, what we can do is we can put the two nth terms equal to each other. Because if the numbers exist in both the sequences, then the nth term will give us the same answer. So n square minus 3 equals to 4 plus 6n. So n square minus 3 minus 4 minus 6n equals to 0. N square minus 6n minus 7 equals to 0. We have a quadratic equation. So what we need to do is we need to solve this quadratic equation. So you can use the quadratic formula or splitting the middle term, whichever you find easy to use. I'm going to use splitting the middle term. So for splitting the middle term, we multiply the coefficient of n squared with the constant. So 1 times 7 is 7. Then you find factors of 7. Factors of 7 are only 1 and 7. So we're going to pick that set of factors and use it to replace the middle term. So n square minus 7n plus n is the same as negative 6n. So basically, this is the same as this. And this 7 comes as it is. Now we split the equation into two groups and factor by grouping. So the first two terms make one group and the last two terms make another group. In the first group, we have n common. So n minus 7 and n comes outside. And the last two terms, we have plus 1 common. So plus 1 bracket n minus 7 equals to 0. Between n and plus 1, we have n minus 7 common. So n plus 1 come in the other bracket. N minus 7 equals to 0. N plus 1 equals to 0. One value of n is 7 and the other is negative 1. Obviously, your number of term cannot be a negative number. So n equals to 7 is one of these. So n equals to 7 is what we'll take. And then we can put this back into either of the equations. So 7 squared minus 3. 49 minus 3 is 46. And over if we do 4 plus 6 times 7, 6 times 7 is 42, plus 4 is also 46. So 46 is one of those numbers that exist in both sequence S and sequence T. Next question says here the first 4 terms of a sequence of fractions. The numerators of the fractions form the sequence of the whole numbers 1, 2, 3, 4, whereas the denominators of the fraction form the sequence of odd numbers 1, 3, 5, 7. Write down expression in terms of n for the nth term of this sequence of fractions. So we can see like in the numerator, it's just 1, 2, 3, 4. In the denominator, we have odd numbers. Now to figure out the nth term for this fractional sequence, if you look at the numerator, we can see that each number is increasing by 1. So using the nth term formula, Tn equals to first term 1 plus n minus 1 times the common difference, which is 1. So that's 1 plus n minus 1, and that's n. So the nth term for the numerator is going to be n. Now for the denominator, the common difference is 2. Each term is increasing by 2. Same thing. First term is 1 for the denominator plus n minus 1 times 2. 1 plus 2n minus 2. 1 minus 2 is negative 1. So 2n minus 1 is the nth term for the denominator. So our nth term for the fraction is going to be n over 2n minus 1. And you can even check that by substituting like n equals to, let's say, 3. So the third term is going to be 3 over 2 times 3 minus 1, which is 3 over 5. Exactly the same as the number in the sequence. So this is how we find the nth term for this fractional sequence. Then it says using algebra, prove that when the square of any odd number is divided by 4, the remainder is 1. So first we need to write an odd number. So odd number would be 2n plus 1. Let's say this is an odd number. So they're saying prove that when the square of any odd number is divided by 4, the remainder is 4. So now we square this odd number. That's going to give us 2n plus 1 times 2n plus 1, which is 2n times 2n plus 1 times 2n plus 1. This is how we expand double brackets. We multiply the first term with both the terms in the second bracket, and then the second term with both the terms in the second bracket. So that's 4n squared plus 2n, and then again plus 2n plus 1. That's 4n squared plus 4n plus 1. Now, they said that we have to prove that the square of any odd number is divided by 4, the remainder is 1. So now we're going to divide this by 4. So when you divide this by 4, we get n squared plus n plus 1 over 4. So this is your remainder. So yes, the remainder is 1. This question is connected with algebraic proofs. So as you can see, they made a mixed questions where the first part was talking about sequences and the second part was talking about algebraic proofs. Even though they're not connected with each other, but like you can get a question where like 2-3 topics are like just in one question. The next question says here the first 5 terms of arithmetic sequence. The numbers are 7, 10, 13, 16, and 19. We have to find the sum of the first 100 terms of the sequence. So we'll use the sum formula which is given in the formula sheet. Sum of first n terms is n over 2 times 2a plus n minus 1 times t. So for the 100 terms, will be 100 over 2 times 2 times 7. 7 is your first term. Common difference is 10 minus 7, which is 3. Plus 100, which is n, minus 1, times 3. That's going to be 50 times 14 plus 99 times 3, which is going to give us 297. So 297 plus 14 is 311. So 50 times 311, that equals 15,550. That is the sum of the first 100 terms of this sequence. Then the next question says that here are the first 4 terms of arithmetic sequence. The numbers are 6, 10, 14, and 18. Find an expression in terms of n for the nth term of the sequence. Once again, same steps. First term is 6. Common difference is going to be 10 minus 6, which is 4. For the nth term, it's going to be 6 plus n minus 1 times 4. 6 plus 4n minus 4. 6 minus 4 is 2. So 2 plus 4n is our nth term. Then write down expression in terms of n for the n plus 1th term of this exact sequence. So this is for the nth term. So if it's t n plus 1 now, what you will do is you will just replace n with n plus 1. That's it. That's the only difference. And then you solve the equation as it is. So 6 plus n times 4, because 1 minus 1 is 0. So that's 6 plus 4n. You could have also replaced this n over here with n plus 1. That's also going to be correct. And also, look at the marks. It's just 1 mark, which means there's no technical calculation. You just have to replace n with n plus 1 and then simplify the expression. If it was saying n plus 2th term, then you would replace n with n plus 2. So we're going to use the exact same expression that we found in part A and just replace the n with n plus 1. That's the only difference between the first part and the second part. And with that, we're done with the sequences questions. Once again, these are the easy questions, and I wanted to solve these first so that you develop better understanding about what arithmetic sequences are and how they work. In the upcoming videos, I'll be sharing the harder questions, which come at the end of the paper 1 and paper 2. And those are the ones which are more technical and like, even though the formulas are the same, but like it requires a little bit more thinking than these ones because these are very straightforward. The other ones are also quite straightforward, but like once again, most students found them to be harder as compared to these ones.